Bismillahirrahmanirrahim. Today I'd like to talk about long division with polynomials. But as an introductory comment, I'd like to suggest the following. Previously we talked about synthetic substitution. And we found this to be very useful. This is when if you're given a polynomial function such as 5x to the 7th minus 6x to the 5th minus 4x cubed minus 3x plus 5, and you're asked to do what is f of 2, you don't substitute this in here directly. Then this is called direct substitution. Okay, that's called direct substitution. But synthetic substitution, if you recall, was when you line up all the coefficients and the constant term and you go through the process of finding what of f of 2 is b. Now we shall review this inshallah next time, but I wanted to suggest to you that we use synthetic substitution for three important purposes. First, we use it basically to find f of x or something, f of 2 for example, or f of negative 1, or f of 5, like this. So we use it basically to find the value of the function for the given domain. So that's one important reason. The second very useful feature of synthetic substitution is actually what we're going to talk about today as preliminarily, and this is for long division. This is the topic of the day. Okay, although we're not going to use synthetic substitution to do long division today, but we're going to learn and review long division the old-fashioned way, and then inshallah next time we'll talk about how to use synthetic substitution in doing long division with polynomials. So the three uses of synthetic substitution that we're going to learn in this chapter are: one, simply to find the value of the function for a given domain, and second is long division, which we'll talk about next time inshallah, and the third is what's called finding zeros. Finding zeros of a function. Okay, this becomes a very important part of the topics that we'll discuss. But before we learn this, we have to go to learn these processes. So these are three important functions, uses of synthetic substitution: finding f of x for a certain value, long division, and finding what's called the zeros of a function. Okay. Today, however, we are going to learn a review long division that we have done before. Excuse me. So let me get rid of this. Now, long division, some students find cumbersome, but I think it's actually not very difficult if you do it methodically. Okay, so let's do this. So we're going to divide x cubed. Let me write it like this over here: x cubed plus 5x squared minus 7x plus 2, and we're going to divide this by x minus 2. So that's what we're going to do, and we're going to do this using long division. So if you recall, you just write x cubed 5x squared minus 7x plus 2, making sure you would fill any missing x terms with 0x. Okay, and then you would put the divisor x minus 2 over here. So just rewrite it like this. You have to apologize. My breathing is a little compromised today, so I'm talking funny. Now, so if you remember, when you're doing long division, it looks kind of hairy thing to do, but if you do it methodically, it's not that difficult. What you do is you just look at the first term here and compare it to the first term over here. And then you ask yourself, what do you have to multiply this term by to get this? Okay, what do you have to multiply x to get x cubed? Okay, in this case, you understand it's going to be x squared, right? If you multiply x squared and x, you get x cubed. So that's what you have to do, okay? And then you multiply x squared, whole thing over here. So you do one of these, so x squared times x minus 2, and then you write it over here. So let's do that. So x squared times x, get rid of this. So x squared times x would be x cubed, and x squared minus 2 would be minus 2x squared, like this. Okay, and then you subtract the 2. Okay, you have to remember you're subtracting, so you have to change the signs like this. Okay, when you do that, this term disappears, and you have 7x squared over here. Okay, and then you bring this term down, okay, because you have two terms over here, minus 7x. Okay, and then you ask yourself, what do you have to do to x to get 7x squared? Okay, what do you have to do to x to get 7x squared? You have to multiply it by 7x. Very good. So you have to multiply by 7x. Now you take the 7x and then you do one of these, 7x and times x minus 2. So you put it over there and you write it over here. So 7x times x is 7x squared minus 14x, like this. And then you remember again, you're subtracting, so you change the signs like this. And then you get, those cancel out, then you get positive 7x over here. Okay, and then you bring this 2 down over here, plus 2. Alright, so now what do we have to do to x to get 7x? That's easy enough. Then you just have to multiply it by 7. So you multiply 7 and the quantity x minus 2. Then you get 7x minus 14. And again, you're subtracting. Don't forget to subtract. You have to change the signs. You're subtracting. So then you get 16. Now this is the remainder, because you can't do anything to x to get 16 really. So that's the remainder. Okay. So when you divide this polynomial by this, the answer is going to be x squared plus 7x plus 7, okay, plus the remainder is 16 over x minus 2. Okay, so this is the answer, because in this case we have a remainder. It's kind of like dividing 15 by 7. Okay, this is 7 goes in there 2 times, that's 14, and then 1 7 is left. Okay, so this is like the remainder. So this is like 2 plus 1 7. Okay, so it's like this plus whatever the remainder is over what you're dividing with. Okay, so that's the answer for the long division over here. Okay, I want to do one more question at the risk of boring you. Let's do this. We're going to divide 3x to the 4th minus 5x cubed plus 4x minus 6, and we're going to divide this by x squared minus 3x plus 5. Okay, so I just want to make sure I copied this correctly from the book. 3x squared minus 5x cubed plus 4x minus 6. Okay, so let's rewrite this again. So 3x to the 4th minus 5x cubed, okay, plus 4x minus 6. Now, I hope you caught that, because there's a mistake. See, in this case we're missing the second degree term, so you have to put a 0x squared over here, okay, to take this spot. So 4x and minus 6. So this is the reason I want to do share this example with you. And then we're going to divide this, okay, by x squared minus 3x plus 5. Again, if you just do it methodically, you just look at the first term. All you have to do is just look at the first terms, okay? You don't worry about this, you don't worry about that. Just look at the first terms. And that becomes reasonably easy. So what do you have to do to x squared to get 3x to the fourth? What do you have to multiply x squared to get 3x to the fourth? Well, you have to multiply by 3, and then you have to multiply by 3x multiplied by 3x squared. So x squared times 3x squared, see, is 3x to the fourth, like that. Okay? So now you get that by just looking at the first terms. Now you take this and you multiply it to all the 3 terms over here, and then you put the resultant over there. Okay? So let's do that. So when you multiply 3x squared and this polynomial here, you get 3x to the fourth. You have to do progressive logic reasoning, very careful, minus 9x cubed, okay, plus 15, 5 times 3 is 15x squared, okay. Now remember, you're subtracting, so just don't do this and then start subtracting. You're subtracting the whole thing, so you have to change the signs of all 3 of these like that. Okay, then you subtract. That's gone, and this is going to be 4x cubed, okay, minus 15x squared. Okay, we got that. Now there are 2 terms here and there are 3 terms here, so they're going to bring this term down over here, plus 4x. Now, what do I have to do to x squared to get 4x cubed? Well, I have to multiply it by 4, and then I also need an x, don't I? So we do that. So now I'm going to take this 4x and multiply to each one of these 3 terms, okay, that, and I put that down over here. So 4x times x squared will give you 4x cubed minus 12x squared plus 5 times 4 is 20x. Okay, again, you're subtracting like this. So that's gone. So that's going to be negative 3x squared minus 16 x. I did that right. Now, what do I have to do to x squared to get minus 3x squared? Okay, then I have to multiply it by minus 3. Okay. All right. So that's easy enough. I forgot to bring this minus 6 down over here from here. Okay. So when I do this, I get minus 3x squared minus 9x minus 15. Okay, I'm sure I did that right. Then again, I subtract. Okay, that's gone. And this is going to be minus 7x plus 9. Okay. If I did that correctly, I didn't do that correctly actually. So because I made a mistake here. This is in positive 9x. So I'm sorry. I should listen to my own words. No, negative 3 times negative 3x is positive 9x. Okay, I was just checking to see if you're paying attention. So minus 15. So if you do this, now we subtract, get positive, negative, positive. That's gone. And I get negative 25x plus 9. Okay? Okay, plus 9. Okay. Now this is the remainder, okay, because you can't multiply this to get this, so that's the remainder. Okay, so when you divide this by this, the answer is, when you divide this too, the answer is going to be 3x squared plus 4x minus 3 plus, there's a remainder, see, plus the remainder, which is negative 25x plus 9 divided by, and what the divisor was, x squared minus 3x plus 5. Okay, so this is the answer to this long division problem. Now, as you can see, this is a bit cumbersome process, and synthetic substitution will actually make this process much easier, make this much easier, and we'll save that for next time. Until then, assalatu wassalamu ala rasulillah wa rabbil alamin. Wassalamu alaikum.